You've probably seen the claim somewhere on the internet. Maybe it was a slick video about simulation theory or a meme that made you stop scrolling. The idea goes like this. The universe, supposedly, only fills in the details where someone is looking. Like a video game that doesn't bother rendering the trees behind you to save processing power, reality itself only sharpens into focus when an observer points their attention at it. Look away and the cosmos goes blurry. Turn back and it snaps into place. It's a haunting thought. It's also one of the most misunderstood ideas in modern physics. So today, let's untangle it. Where does this claim come from? What's actually going on in the experiments behind it? And what does science genuinely say about a universe that may, or may not, exist when no one is watching? The claim almost always traces back to one experiment: the double-slit experiment. It's a deceptively simple setup that has been called the heart of quantum mechanics, and Richard Feynman himself said it contained the only real mystery of the quantum world. Here's the basic idea. You fire tiny particles, electrons, or single photons of light at a barrier with two narrow slits cut into it. Behind that barrier sits a screen that records where each particle lands. If particles behaved like little marbles, you'd expect two neat stripes on the screen, one behind each slit. But that's not what happens. Instead, you get an interference pattern, multiple bands of light and dark, the kind of pattern you'd expect from waves rippling through both slits at once and overlapping on the other side. Even when you fire the particles one at a time, with minutes between each shot, the pattern still builds up. Each lonely particle somehow seems to pass through both slits, interfere with itself, and land in just the right spot to contribute to that wavy pattern. Now here's where things get genuinely weird, and where the observer mystique was born. If you place a detector at one of the slits to figure out which way each particle actually goes, the interference pattern vanishes. The particles start behaving like ordinary marbles again. Two simple stripes, no waves, no interference. The very act of finding out which path the particle took seems to change what the particle does. This is where pop science usually leaps off the cliff. The narrative becomes, the particle knows when it's being watched. Consciousness collapses reality. The universe checks for observers before deciding what to render. Cue the dramatic music. But here's what physicists actually mean by observation. And it has almost nothing to do with eyeballs or minds. In quantum mechanics, observing a particle simply means interacting with it in a way that extracts information about it. To detect which slit a photon went through, you have to bounce something off it, another photon, an electromagnetic field, anything. That interaction is the measurement. And that interaction is what disturbs the system. The Wikipedia article on the observer effect puts it bluntly. The need for the observer to be conscious is not supported by scientific research. It is, quote, a misconception rooted in a poor understanding of the quantum wave function and the quantum measurement process. A dead, unconscious electronic detector causes the same effect as a graduate student squinting at a screen. The cosmos doesn't care if you have a PhD or a pulse. So if it isn't consciousness pulling reality into focus, what is going on? The modern answer involves something called decoherence. In the quantum world, particles can exist in a state called superposition, a kind of fuzzy combination of multiple possibilities at once. An electron, before measurement, isn't really at slit A or slit B, it's in a delicate mathematical state that includes both. That superposition is what allows the wave-like interference pattern to form. The catch is that superposition is fragile. The moment a quantum system gets entangled with its environment, with stray air molecules, with thermal photons, with literally anything that carries away information about its state, the wave-like behavior unravels. the system decoheres. It stops behaving like a wave and starts behaving like the classical world we're used to. This happens constantly, everywhere, with no human required. A speck of dust floating in deep space is being battered by photons from the cosmic microwave background, the leftover heat from the Big Bang, which has been bathing the universe in radiation for nearly 14 billion years. The moon is constantly being struck by sunlight, by particles from the solar wind, and by cosmic rays. Every one of those interactions is, in the technical quantum sense, a measurement. The moon is being observed by the universe itself, trillions of times a second, whether you're looking up or not. Einstein once asked his colleague a famous question while walking back from the Institute for Advanced Study in Princeton. He pointed at the night sky and said, "Do you really believe the moon isn't there when you're not looking at it?" Einstein thought the answer was obviously yes, the moon is there. The reality of the world shouldn't depend on whether some human happens to be looking. Modern physics has a nuanced response. The moon, as a large object made of countless particles in constant interaction with their environment, has effectively decohered into a definite state long ago. It doesn't blink in and out of reality based on your attention. The interference effects that make quantum particles seem ghostly only show up for tiny, isolated systems carefully shielded from their surroundings. Your coffee cup, your dog, the Andromeda galaxy, none of them are sitting in some pixel-conserving low-resolution mode waiting for you to glance over. Now, does this completely settle every philosophical question about reality? No. Physicists genuinely disagree about the deeper meaning of the wave function. The Copenhagen interpretation, the many worlds interpretation, pilot wave theory, and others all give different answers about what is really happening underneath the math. That part of the debate is alive and well, and honest scientists will tell you we don't have a final answer. But none of the mainstream interpretations say that consciousness creates the universe, or that distant galaxies wink out when nobody's looking. Here's the thing, though. The actual story is, in some ways, even stranger than the simulation theory version. Reality at its smallest scales genuinely doesn't behave like the world of marbles and billiard balls we evolved to navigate. Particles really do exist in superpositions of possibilities. Information really is the currency that turns the probabilistic into the definite. The universe really does have rules so counterintuitive that the brightest minds of the 20th century lost sleep over them. You don't need a simulation to find that astonishing. You just need to look closely and let the strangeness be what it is. If this kind of cosmic mystery makes your brain itch in the best possible way, hit subscribe. Drop a comment with the quantum question that's always confused you, and I'll see you next time, when we ask whether time itself is even real. Until then, keep looking up. The universe doesn't need you to, but it's still worth doing.